Okay, so today we're going to start with polygons. And in order for us to continue with polygons, we have to know the very basics. So there's a lot of vocabulary in today's video that you need to know in order to understand and to move ahead with polygons. So let's start at the very beginning, which is the definition. A polygon is a closed plane figure with at least 3 sides and angles. Now we know that the most basic polygon we've learned since we were 3 or 4 years old is a triangle. A triangle actually is a convex figure. Convex means that all of the angles are facing outward, as opposed to concave figure. We can have concave polygons. Concave polygons means at least one of the angles is facing inward or in on itself. This is a concave polygon. Polygons are named by the number of sides. If I have 3 sides, it's a triangle. 4 sides is quadrilateral. 5 sides is a pentagon. 6 sides, hexagon. 7 sides can be a heptagon or a septagon. Octagon is 8-sided figure. A 9-sided figure is nonagon. A 10-sided figure, decagon. A 11-sided figure has hendecagon or undecagon. And a 12-sided figure is a dodecagon. We can also have an n-gon, which means that it has n number of sides. Equilateral. Equilateral in itself really just means all sides are congruent. Like in this rhombus, all of the sides are congruent in this rhombus. The angles are not all congruent, but the sides are. If all of the angles were congruent, that would be equiangular. Like in this rectangle, all of the angles are 90 degrees, but you can see the sides have different measures. So rectangles are equiangular. But what if they are both equiangular and equilateral? Then that is a regular polygon. An equilateral triangle is really a regular polygon that was just given the special name of equilateral triangle. Same as a square. A square was given a special name, but it's really a regular quadrilateral. All right. Another vocabulary that we need to understand in order to move forward with our study of polygons are diagonals. Diagonals are line segments that connect two non-adjacent vertices of the polygon. So I'm going from this corner to that corner. That's a diagonal. And same from here. But what about in a pentagon? Where are my diagonals? Well, according to the definition, it connects two non-adjacent vertices of the polygon. Yes, that is a diagonal. There's a diagonal connecting two non-adjacent vertices of that polygon. There's another one, and yet another one. Diagonals connect two non-adjacent vertices of the polygon. Now, let's talk about how to name the polygon. So, it doesn't really matter. You name it by the vertices, okay? Each vertice comes together at a point, which we use capital letters for. And it doesn't matter where you start on your polygon. You can start anywhere you want. I tend to start various places, but I almost always go clockwise if I have a choice. And so I'm going to name this Veronica, Veronica. Now, let's look at another vocabulary word called the central angle. The central angle of any regular polygon is equidistant from the vertex to the center. So any vertex. So I'm going to go down here from I to the center and N to the center. I have now formed a central angle. Okay, the central angle is 360 divided by N, N being the number of sides. 360 in this case divided by 8 is 45 degrees. So the central angle of any regular octagon is 45 degrees. Okay, now we're just going to talk about the interior angles of polygons. And this case, on octagon VERONICA, we are going to note that the sum of the interior angles of any polygon is the quantity of n minus 2 times 180. N is still the number of sides. So the sum of the interior angles of any octagon, regular or not, the sum of the interior angles is 6, so 8 minus 2, 6 times 180, which is 1080 degrees. Okay, that means that if I added all of these up, I get 1080 degrees. But if this is a regular octagon, which we know that it is, each interior angle would have a measure of 135 degrees. Well, how did I get that? Well, I simply divided 1080 by how many angles there are. There are 8. And so each interior angle would measure 135 degrees because there are 8 of them. 8 times 135 gives me 1080. Now, guess what? We also have exterior angles. So this is a regular pentagon, and each interior angle measures 108 degrees because it's regular, and all I did was take 3 times 180, 5 minus 2 times 180, and I then divided that by 5, and I got each one is 108 degrees. Now, that's the interior. But if I had the exterior angle, you say there's no exterior angle. Yes, there is. The exterior angle of any polygon is between the angle between any side of the shape and a line extended to the next side. So here it is. And notice that we have here this one plus this one, and what do you notice? They form a linear pair. That means that each one of these add up to 180. So 108 plus 72 gives me 180. Now, let's just for fun find out what the sum of all the exterior angles of the pentagon is. And in this case, they are all 360 degrees. 72 times 5 gives me 360 degrees. Let's just keep that in the back of our minds for a moment. Okay? We're going to move on, but we are going to come back to that 360 degrees. All right. So let's look at this. All I know is that it's a quadrilateral. It looks like it's going to be a parallelogram, okay? I don't know that because there are no markings. Keep that, remember that. You can only tell if it's given to you either in markings or in writing. So all I know right now is that I have a quadrilateral. I also know that each one of these angles, N and N, 2N and 2N. I want to know the measures of the interior angles. Okay, well, I know that every quadrilateral, no matter what it looks like, has a sum of 360 degrees. I also know that I can add these together, 2N plus 2N plus N plus N, and that should equal 360 degrees. So 6N equals 360. When I divide 360 by 6, I get 60. So N stands for 60. That means that that angle is 60 degrees. That angle is 60 degrees. That angle is 120 degrees. And that angle is 120 degrees. Okay, so now let's find the exterior angles of the same quadrilateral. Well, I know that if I extend this angle, 120 plus 60 gives me 180 degrees. 60 plus 120 gives me 180 degrees. 120 plus 60 gives me 180 degrees. And 120 plus 60 gives me 180 degrees. All right, so if I added all of those up on the exterior, what do they add up to? Well, the interior are the same measures, exterior as the exterior in this case, and that was 360 degrees. Okay, and remember what we just did when we did the pentagon. What was the measure of the exterior angles? 360 degrees. So it doesn't matter. The sum of the exterior angles measures are always 360 degrees. All right, we have 3 theorems that we've learned today. The first one is the polygon angle sum theorem, which is the sum of the measures of the interior angles of an n-gon is n minus the quantity of n minus 2 times 180, where n is the number of sides. I have here 5, and so 5 minus 2 times 180 is 540. Now, we have a corollary, to polygon angle sum theorem, which means it's just kind of an addition, and it says the measure of each interior angle of a regular n-gon is the quantity of n minus 2 times 180 divided by n. N is still 5 in this pentagon. 540, which we found out before, was the total, was the sum, divided by 5 is 108. So each interior angle of the regular n-gon is the quantity of n minus 2 times 180 divided by n. And the third theorem is polygon exterior angle sum theorem. The sum of the measures of the exterior angles of a polygon at each vertex is 360 divided by n. So 360 divided by 5, the exterior angles of each one of these is going to be 72 degrees. Well, that's it for today. You now should have the basics of polygons, and we'll be ready to get started on the next video. Until later, bye-bye.